Now we're going to start looking at limiting and excess reactants in our stoichiometry. Now for the junior set you would have encountered the reaction between iron and sulfur to give you iron sulfide. Now if you're looking at the chemical equation on this, you'll have Fe plus S gives you FeS. Now from that there we can deduce that the ratio in which they react, which is very important in stoichiometry, is 1 is to 1 is to 1. But say for example we had 4 atoms of iron and we had 6 atoms of sulfur. Now when we're going to form our iron sulfide, our compound iron sulfide, so 1, 2, 3, 4, one of the wee black dots is going to bond with one of the wee red dots. So what has happened here? We have 2 left over. So we have 1, 2, 3, 4, 1, 2, 3, 4, 2 of these sulfur atoms left over at the end. So when there is extra amounts of atoms, say in this case sulfur, this is known to be an excess, and this is known to be a limiting. Now they're known as limiting or excess reactants, as reactants are what is on the left hand side of our chemical equation. So in this case are iron and sulfur. What's formed, like in a factory, is known as our product or products. In this case it's only one product, our iron sulfide. Now from this, what determines the amount of product formed is our iron, the limiting reactant. So the important thing here in equations, we work with the limiting reactant. It dictates how much product is formed because we have left over our excess reactant. So the limiting reactant determines how much product is formed. So we've got a little example here, it'll be in your notes. Maybe attach that below the video and I'll go through these in more detail. We have zinc and sulfuric acid forming zinc sulfate and hydrogen. Now in this, again, before you go about any of these calculations, if you write down the ratio of our reactants and products just above or below the equation here, so it's a 1 to 1 to 1 to 1 ratio again, which makes things easier. Now I've summarized the information. They've told us that 9.8 grams of sulfuric acid was used in this here and 13 grams of zinc was used in the chemical reaction. Now what do we always go back to in chemistry? We always go back to our moles. And when you're dealing with your moles, we're going to be looking at our mole triangle. So number of moles in the middle. We have our mass in grams at the top. So when you're going back to moles, anytime you're going back to moles in the center of this triangle, you're dividing. So if I had 12 grams of carbon, I have 1 mole of carbon. If I have 24 grams of carbon, I have 2 moles of carbon. So how do you go back to moles? You divide by the relative molecular mass. And if you're leaving moles, if I have 1 mole of carbon, or 1 mole of carbon, I have 12 grams of carbon. I have 2 moles of carbon, I have 24 grams of carbon. If I have 3 moles of carbon, I have 36 grams of carbon. So what are you doing there? You're multiplying. So when you're leaving moles, going out from the center, you're multiplying, in this case, by the relative molecular mass. So, in this one here, show that zinc is in excess. So we know that when we work out the number of moles of zinc, we're going to have a higher figure. So you'll need your periodic table in this and look at the mass numbers of each of them. So we'll go back to the number of moles of our sulfuric acid. So number moles H2SO4. We're told that we've got 9.8 grams. To go back to moles, as we see over here, we divide by the relative molecular mass. Now you've got to work out the relative molecular mass of sulfuric acid. If you look at your periodic table, 2 by 1 for your hydrogens, 2, 1 sulfur atom, 1 by 32, 32, and 4 oxygens. You add those all up and you get 98 grams per mole. So 9.8 grams divided by 98, and you divide that there in your calculator, you get 0.1 moles. Now we know by the way this question's phrased that this is the limiting. This is going to determine the amount of product formed, but we've got to show it. So now we're going to work out the number of moles of zinc. Similar fashion. So we've got 13 grams of zinc. To go back to the number of moles, mass in grams, 13 grams, divided by the relative molecular mass. If you look up that transition element, that D block element of zinc, used in galvanizing, you get a relative molecular mass, a relative atomic mass of 65. Throw that in your calculator and you get 0.2 moles. So you can see from this a bigger figure. So once we've got these actual number of moles, throw them back into the equation using the ratio, and we're working with the limiting, the smaller amount. So 0.1 moles of sulfuric acid. That's all in a 1-to-1 ratio. So it's all 0.1 moles. We'll look at ones where it's not in a 1-to-1 ratio throughout. Now find the mass of zinc sulfate formed. Now we know there's 0.1 moles of zinc sulfate. We've got the number of moles. To go to mass in grams this time, you multiply by the relative molecular mass. Foam roller's doing a great job here. So 0.1 moles multiplied by the relative molecular mass of zinc sulfate. We'll just have to work that out. 1 zinc, so 1 by 65. 1 sulfur, 1 by 32. And each oxygen atom has a mass